First, we can discuss the tutorial that was given by last week. Uh, that is about regression and regression correlation analysis and chi-square test. Below is a sample data set. Below is a sample data set of heights and weights of 10 men. So heights and weights given here. Draw a scatter plot for the above data. Use the SPSS to generate. Use the SPSS to generate model summary, ANOVA and the coefficients. Interpret the regression output. Determine whether height significantly predicts the weight. Right. So first we can enter the data to the worksheet. So height and weight we have to enter. It's given in this table, right? Height in inches and weights in yeah. So then 69, 70 requires we can enter these to the two columns by defining these columns, right? Views. First one is you can see here in the variable view, we can define the variables. So height and weight, those are numerical variables, right? So in the data view, we can add these two, right? So the first thing is we have to draw a scatter plot. Yeah, draw a scatter plot. So, graphs, legacy dialogues, scatter. Then simple scatter. Then y-axis is weight and x-axis is height. So then we can draw the scatter plot. Yeah, this is the scatter plot. So you can see here there is a positive relationship, right? So the relationship is positive. Second one, in the second question, it's given, yeah, use the SPSS to generate model summary, ANOVA, and the coefficients. Right. So, and interpret the regression output to determine whether heights of significantly predicts the weight. Okay. So then we can go again. So analyze regression, linear, linear regression, right? Dependent variable is weight, independent variable is height, right? Height significantly predicts the weight. That is a question. So therefore, dependent is weight. Okay, statistics, yes, model fit, R square, descriptives we can take, right? Yeah. Then it's ask about the plots. Right. So if you like, so normal probability plot we can draw and options given here. Okay. Then we can go, okay. So then this is the output. The descriptive statistics are given here. Mean for the weight is 176.70. The standard deviation is 33. The height is 69.90. Then correlations are given here. Pearson's correlation, that is, here you can see 0.860. That is closer to 1 as showed in uh, the scatter plot. So you can see that is closer to 1. It is 0.860 in between the Pearson correlation in between height and weight. Yeah, so then we can take this ANOVA table. So you can see here R square change, adjusted R square value is 0.740. It means 74% of the dependent variable is explained by the independent variable. 74%. So normally you know that it should be, if it is very good model, it should be greater than 80%. So here 74%. So that is quite closer to the 80. Therefore, that is also a good model to predict actually. So you can use this data to predict the outcomes, right? So then this is the ANOVA table. So you can see here. Okay. And the most important one is the coefficient table. So you know here, uh, constant is negative 441.793 and the uh, gradient is 8.848. So you can see here the this normal property plots also here, right? Yeah, so then the thing is that so we can write the regression equation here, right? So the regression equation by looking at uh, the coefficient table, you know, we can see the output here. Output here is then we can write regression of y equals a plus bx, right? Y equals a plus bx is the formula. Y equals a plus bx, that is actually the formula, right? That is the formula. Then we can write here. So our dependent variable is here the weight. No? So therefore, y means weight equals to what? Negative 441.793. So that is the coefficient given here. And plus the gradient is 8.848 times x. X is our independent variables, that is height. So we can write within brackets height. So that is a regression equation. Then by using this, you can predict the weight based on. So for suppose height is given in a weight. No? So suppose the height is equals 5.5 inch, right? 5.5 inch because according to the given data, it's given in inch, right? So then we can find weight. We can find weight equals to negative 241.793 plus 8.848 times height now 5.5. Then we'll see what is the value here. Weight equals to negative 441.793 plus yeah. So then we can multiply this 8.8 right? After simplifying this, you can calculate what do you call calculate the uh, required value, right? Therefore, why here we can use this formula to calculate the regression equation. So that is what you can do. That is not given actually, but if we know one variable, so we can find the other one after modeling this regression equation. Right. The second question. A chicken farm owner tests a new feed supplement to increase egg production. The dataset consists of 12 of 100 chicken each receiving different supplement levels. Group feed supplement number of eggs is given. Right. Draw a scatter plot. Again, you have to draw a scatter plot. Formulate null and the alternative hypothesis. Use SPSS to generate model summary and ANOVA coefficient for those things. Right. So then, therefore, we can write here there is no relationship between the feed supplement and number of eggs. That should be the null hypothesis. Right. Then, first thing is you have to draw a scatter plot. Right. But this is the data set, so we can enter. Group is there, food, feed supplement, and number of eggs, right? Number of eggs. The question is, so you need to draw a scatter plot. So we can go graphs, legacy dialogues, scatter dot. So then simple scatter we need. Then y is number of eggs, x is feed supplement. So then we can go the scatter plot. So then here you can see that there is a positive relationship, but it's not. This is not quite high because this you can see there is very much spread there. Okay. Then can calculate the regression. So analyze regression analysis, analyze yeah, regression, linear regression. So dependent variables number of eggs, independent variables food supplement. Okay. Then these are the regression tables, right? Then here I told then here the value is R is square 0.5. 0.5 is not a very large positive relationship there. And the other one is R square value is 24.9. 0.249 means 24.9. So therefore, this model is not good actually to predict because I told you that. So R square value should be greater than 80% actually to say that that is a good model. Therefore, this is not a good model to predict the outcomes. So anyhow, we can find this ANOVA table is in here. And so you can find the significant value 0.099 that is less than 0.05, 0.09. It is less than 0.05. No, 0.09. 0.09. It is greater than 0.05. Therefore, it's failed to reject the null hypothesis. It means there is no significant difference actually. It means it's not predict that one. That's what I told you. මේක එන විදිහට ඒක predict කරන්නේ නැහැ. මොකද we can reject the null hypothesis. Then we can write our regression equation. So that is y is feed supplement equals to 77.268 plus 0.58 within brackets we can write uh, number of x is dependent variables. Therefore, we can write number of x equals 77.268 plus 0.580 times feed supplement. So that should be uh, the regression equation. Third question. A psychology student examines the long-term effects of alcohol on reaction time by measuring response time and self-reported alcohol consumption per week. It's given reaction time and alcohol consumption units. Yeah. Then draw a scatter plot, compute the Pearson and Spearman's correlation coefficients, interpret the correlation results, explain whether alcohol consumption significantly affects to the reaction time. So then this is about correlation. So we can enter the data. Here we can in variable view consumption numeric, time is also numeric. So then we can enter this data that was given in the table. So then we need to calculate correlation. So therefore, analyze, correlate, bivariate. Then variables are these two. Then I need Pearson, both Pearson and Spearman correlation. Yeah, then this is the Pearson correlation. So you can see here 0. Before that, you need to, we need to draw a scatter plot before, right? This is, we can keep here correlation. So I'm going to draw a scatter plot. This is a scatter plot. So you can see there is a positive correlation. So the positive correlation actually, positive correlation. So we can see that correlation in here. The correlation is 0.805 actually, that is closer to 1, right? So this is the Pearson correlation, 0.085, 0.805. Then that is the Pearson correlation. So we can calculate this PMN correlation as well. That is non-parametric. That is actually quite similar for this one, 0.809. There is no more differences. So these two, according to these two tests, Pearson and PMN, so actually correlations are significant actually. Yes. Yeah. Then question number 4. It is about multiple linear regression. So you can see here one dependent variable and many independent variables are there. The dataset below examines study habits, sleep duration, and exercise routines influence students' academic performance. So therefore here the dependent variable is actually the students' academic performance. And the independent variables are the others. That is uh, sleep duration, exercise hours, those things. And sleep hours. Right. First, we can enter this data and calculate the mean, median, and standard deviation for study hours, sleep hours, exercise hours, and the exam score. Right. Study hours, sleep hours, exercise hours, exam score. So we can enter this here. You can see the variables, all are numeric variables, right? And the first question is calculate mean, median, and standard deviations for this. Therefore, we can go analyze descriptive statistics. Then we can go for descriptives, options. Yeah, it's here. Then we can take this all. Then we have to calculate mean, median is not there, no? Yes, it's not here. Then we can go for another one. Analyze descriptive statistics. I will go for explore. Plus. It will be yours or not? Plus. Plus. Options. Plus. Yeah. So then we can go again. Exploit is also not towards for that one. Analyze descriptive statistics. The other one is frequencies. For that, we can go to statistics. Here it's mentioned everything. So therefore, we can take from the frequencies. The frequency tables are not wanted there. So then we can see here we need to calculate mean, median, and standard deviation. Okay, statistics we need mean, median, and standard deviation. Okay, then okay. So this is the output. Mean, median, and standard deviation for everything is in given in one table. Right, mean for study hours is 5.55, sleep hours 6.50, exercise hours 2.15, and exam score is 87.2060. Medians are 5.507, 2.5, and 87.6. And last one, standard deviation actually, 2.64, sleep hours 1.7860. Right, the next one. Compute the correlation coefficients between study hours, sleep hours, exercise hours, the exam score. For each and every four, we have to calculate the correlation coefficient. Then we can go analyze, correlate, bivariate. So we can have this all. These are the correlations. Right? So you can see here the relationships between study hours and sleep hours. Negative relationships, that's okay. Right? So it means if the study hours increases, that sleep hours should be decreases. So that is a negative relationship. Good. Then exercise hours, it means the value is right. Next one. Right. Right. The next one is perform a multiple linear regression with exam score as the dependent variable and study hours, sleep hours, and exercise hours as the independent variable. So then we Then here we have to calculate. There are many independent variables. Dependent variable is exercise hours, but there are many independent variables. Therefore, uh, we have to go for multiple linear regression. So um, yes, we can go analyze regression linear, right? So dependent variable is exam score. Independence here, so we can take all here, right? Independent variables, right? So model fit, okay, R squared descriptives. Uh, we can take what we want. Plots also there. Options. No need to change anything here. Just you have to take this. So you can click on and see what is given in there. Right, then okay. So this is the output here. Model summary. So you can see here R correlation is given here. R is predictors 7.9 0.794 0.794, and so you can see there ANOVA value is also there, so that is 0.01. The coefficients given here, so this is actually what we need to do. So its question is given. Uh, write the equation based on the coefficient obtained. Yeah, we can write the equation of uh, the regression line, right? We can write the equation actually. I will write. Can write the equation. That is dependent variable is exam score. Therefore, we can know the exam score is equals to exam score is equals to constant is 53.043 plus then study hours that gradient is 3.117. 3.117 times what? Study hours plus study hours plus the other one is 2.121. 2.121 times sleep hours plus the last one is 1.433 times exercise hours. Right, so this is the regression equation. So once you know these things, the study hours, sleep hours, and exercise hours, so you can predict the exam score. Right, once you substituted these values, so we can predict these exam score. මේවා දන්නවා අපිට exam score එක දැන් හොයාගන්න පුළුවන් because we have a model. So this is a mathematical model there. Which predictor variable has most significant impact on the exam score? All right, what is which score? Because that here we can see here what is the gradient high is 3 point study hours. Then what is the question? Equation is based on the coefficient model. So that is predictor variable is study hours. Are any predictor variables insignificant in the model? Justify your answer using the p-values. Yes, we'll see. All are significant as I think we'll see that on our table here. These three. Yeah. So one is there. So study hours, sleep hours, and constant, those are significant, but exercise hours are not significant. So because that is greater than 0.05. So that thing you can report here. What is the R squared for the model? What does it indicate? So here R square value is 0.630. So if we convert this into a percentage, that is 63%. So actually I told you that if it is a good model, so that R square value should be greater than 0.8. It means 80%. So then here it is less than 80%. It means that this is not a very good model to do the predictions. Make the model because the R square value is this value. R square value is not 0.8 or higher. So then we can say it's good model. Based on the regression model, yes, then we have to calculate. So based on the regression model, predict the exam score for student. Yeah. So we have to do a prediction. We'll see exam score prediction. Right. So it's given study hours. Study 6 hours per day. Study hours. So here 6 hours per day. Sleep 7 hours. The sleep hours here 7. Sleep 7 hours and exercise 3 hours. 3 hours. 3 hours exercise. 3 hours. Then we can do the calculations and find the exam score. We'll see 53.053 plus 3.117 multiplied by 6, that is 18.702 plus the other one is 2.121 multiplied by 7, 2.121 multiplied by 7. The answer is 14.847 plus the last one 4.299. Then we can find exam score. It is equals to, we have to add this all 53.053 plus 18.702 plus 14.847 plus 4.299. 53.0543 plus 18.702 plus 14.847 plus 4.299. This is approximately equals for, yeah, the value is approximately equals to 91. So the exam score is 91 day. Exam score is 91. Right. Then there are many questions related to this one that you can try it. So then last, there are another two questions about chi-square test. So then this one again, so for the categorical variables or the for non-parametric variables, so we can perform chi-square test. A survey of supermarket employees recorded their attitudes towards weight restraint based on their job type. Job type neutral, oppose, support. Cashier, cleaner, manager, stocker. Set up contingency table, compute the chi-square statistics using SPSS, determine whether the job type was associated, explain the significance of finding. So, there are many, you have to enter this data. This is cashier neutral, cashier oppose, cashier support. Likewise, you have to enter and then counts, right? So we can, after enter, you can see like this. Then there should be here 9 entries. Yeah, or 10, 9. Here we have to enter job type. So here 1, 2, 3, 4 I define there. One is for yeah, you can see here job type we have to enter. For job type, so we can define the values. 1 for supervisor, 2 for shelf stacker, 3 for till operator, and 4 for cleaner. And also sex here it's mentioned 1 for male and 2 for female, right? So then we can enter the data. Yeah. Job type is 1, sex is 1, likewise. Yeah, that's it. The counts are given here. Counts are given there. The problem is with counts. So that is actually different than this one. Yeah, here job one is neutral. Actually, the values are different. Supervisor, no, no, not this question. That is a different one. Ah, yeah, this is the question. Okay, sorry. Then here job type, male, female. Yes. Then it's okay. Then we can enter like this, right? So then we can go compute the expected frequency, assume no association. Use the SPSS for form of chi-square test of independence. Interpret the test results. Conclude whether the gender type are independent. Right. Then we'll go for the chi-square test. Uh, Analyze descriptive statistics, cross steps. Before that, we have to weight this. Then we can go data, weight cases, weight according to count. So that is the first thing you have to do. Then we can go analyze descriptive statistics, cross steps, cross steps. For rows, yeah, for rows, what? For rows, for rows, job type. Job type is for rows. Columns for six. Then it's needed. Yeah. Chi-square test. Okay, then cells, we need the expected frequencies as well. We can see here. So the expected frequencies, the expected count also here. So the question is given, so we need to calculate the expected count as well. Then the most important thing is the Pearson chi-square value is 16.409. That is right. So that is how we can perform chi-square test. Right, final question. Last one. Right. Here also the same thing. Uh, and then there is a question here. Gender is job types are independent. So then we can write there is a relationship in gender and the job type. So then our uh, chi-square value is yeah, that is 0.001. It is less than 0.05. Therefore, we can reject the null hypothesis. Right. So therefore, actually, it's yeah. So job there is a relationship here. So then we can write the conclusion. Yeah. Gender and job type are not independent because gender depends on the job type depends on the gender. Right. Okay, next one, explain the significance of the findings. So determine job type and wage attitudes are associated. So then we can write that our uh, null hypothesis, there is no relationship between job types and the wage attitudes, right? Uh, right, last question. So we can enter this data over here, variable leave. So you can see here, job types are defined here, cashier, cleaner, manager, stocker. So then here you can see 1, 2, 3, 4, neutral, opposite, support. Right. The question is first contingency table. So then we can go data, weight cases, weight by count. That is the first thing. Then we can go analyze descriptive statistics, cross steps. Rows. Rows are, what is rows here? Job type. We need chi-square value and we need expected frequencies. That's all. Then you can see here these are the relationships. And the chi-square value is 52.312 and it is significant. 0.00 is less than 0.05. So then we have an alpha which is right. There is no uh, relationship between the job type and the attributes are associated. Then here you have to say yes, that is associated. Right? The value is 0.00. That is actually a good value. Yeah, those are the things we discussed in the last day. Right, today we can go for the last lesson actually. So we are trying to discuss about the fact analysis. So then here we are discussing about the factor analysis. So these are the learning outcomes of today's lecture. At the end of this lesson, you will be able to understand the purpose and application of the factor analysis, differentiate between principal component analysis and common factor analysis, perform principal component analysis and in SPSS and interpret key outputs, apply principal axis factoring and maximum likelihood, use Varimax and direct opt-in rotation methods, generate and interpret factor scores for further analysis, apply factor analysis techniques to simplify data and identify key patterns. Yeah. You know, this is actually, I think this is actually quite a theoretical part first I will tell you because in here so there are two types of variables. One is the observed variables, the other one is latent variables. Some of the variables are there, right? Actually those construct we can't measure directly. සමහර ඒවා measure කරන්න බෑ directly. Right, for an example, so here SPS is anxiety. So there is no scale to measure the anxiety. So therefore, we are asking some questions. These are the observed variables. There are 8 items there. By these 8 items, right? By these 8 items, we can take uh, combine and take as the SPSS anxiety. So then here assumptions, all the correlations among all variables can be explained by the latent variable, right? So I think you got the idea, latent variables and the observed variable. Latent variable is created by uh, taking many informations from these observed variables. Yeah, so then these are the 8 items here in the questionnaire, right? A dream that Pearson is attacking me the correlation coefficients. I do not understand statistics. I have little experience with computers. All computers hate me. I have never been good at mathematics. My friends are better at statistics than me. Computers are all, computers are useful only for playing games. I did badly at mathematics at school. Right, these are the 8 questions given in that question actually. So we have to, yeah. So these questions are given in the questionnaires. So this is the questionnaire. These 8 questions are there. Statistics may cry. My friends think I'm stupid. I'm not being able to cope with SPSS. Standard deviations excites me. I dream that person is attacking me without a correlation coefficient. I have little experience with computers. I don't understand statistics. All computers hate. And last one is I have never been good at mathematics. There are some terminologies I will explain briefly to understand what is it. Common variance and unique variance. Right. So you can see here, as I explained there, so this is the SPSS anxiety. So it's created by these items because it is not an observable variable. The total variance made up with the common and unique variance, right? Right, fact extraction type model. So principal component analysis, exploratory fact analysis we can use. Right, then we'll see how we can extract the factors. We are going to use principal component analysis for two components. Common factor analysis, that is principal factor, access factoring, and maximum likelihood. Right, there are many methods to extracting these factors. Principal component analysis, PCA, to replicate the correlation matrix using the components that are fewer in number than the original set items. Right, so then here you can see here that correlations are there. Right, so then here you can see the variables. Here you can see the correlations here within these eight, right? Eight questions. So questions are collected through the question, yeah. Right. Eigenvalues and eigenvectors. Right, eigenvalues. Total variance explained by given principal component. Eigenvalues should be greater than zero is good, and negative eigenvalues ill conditions. Eigenvalues close to zero is multicollinearity. So then you have to, based on the eigenvalues, so you have to, you are going to divide this into the questionnaire development. So we can use this eigenvalue section. Eigenvectors, common component loadings, correlation of each items with principal component. Eigenvalues are the sum of square component loadings across all items for each component. Right. So then here it's mentioned that how to run the uh, PCA with eight components. Right. So we'll see how we can go for the fact analysis. That is principal component analysis. So it's mentioned that analyze dimension reductions factor. So that is the method. Right. Okay. So we'll follow the instructions given here. Right. This is the given data set. Right. Actually, there are many. There are 2,571 entries here. Right. According to these eight questions. So this is question number one, question number two, and these are the actual questions. Question number one is this one. Right. It's given Statistics make right. So then here you can see strongly agree, disagrees one, strongly agrees five. So the ninth one is not answered. Right? There is no answer for the questions. Then all are in ordinal measurement, ordinal measurements. Right? Then we can enter these data. Yes, okay. Then we can go analyze, right? Analyze dimension reduction factor. That is the way we have to do. Analyze dimension reduction factor. So then we can go for principal component analysis, factor analysis. So we have to, yeah, select all is okay. Then we can go method. Method here you have to mention as principal components and analyze correlation matrix. That's okay. Scree plot also we can go here. And so we are going to, for these options, fixed number of factors, fixed number of factors here. It's, you can name it as 8. Then iterations for conserve is 100. Right. Then this one is, we can take this table is there. Then you can see component loadings are here. Correlation of each items, the principal components. And so these are the, yes, you can see here, statistics may cry. Right? So then we go for the principal component analysis. Then we took this table. Yeah. Then it's mentioned that, yeah, component loadings and some of the square loadings across the component is combined. It means we have to, we have to add this whole, then we can take this communality. Right. Total variances experienced here. So you can see there. Like here, you can take this. This is the output. Total variance explain is this table. It is here, right? Next one, this is a tree plot. So this is just like an elbow, right? Why eigenvalues are better than one criteria. And recall eigenvalues represent total variance explained by the component. Right. Then, so then here got for eight factors. Now then we are going to do the same process for two factors. So only the thing is we are changing this one to two. Right. Right. We can go again analyze. So analyze dimension reduction factor. Analyze dimension reduction factor. Then we have only two. Right. Then we took the output. Right. Only changes. So the fixed numbers factors eight. Change it eight to two. So you can see here 3 point. Right. There are only two eigenvalues there. So this is 2, 3.057 and 1.060. Right. It means you can you can what do you call we can summarize actually for two. This there are eight questions, so then we can take for two here, right? Because of this, only two eigenvalues are there, right? And the other one is this is 80, right? And next one is extracting factor for the exploratory factor analysis. That is actually what do you call that is the common factor analysis. Also reduced dimensionality, but assume total variance can be divided into common and unique variances. Makes more sense to define construct with measurement error. Right, the same thing. So then now we are going to do the exploratory factor analysis, earlier principal component analysis. Right. So one variable is a fact. Okay. There are eight variables. So then now we are using principal axis factoring. So the thing is then fixed number of factors to maximum iteration of convergence, that is again 100, right? So we can go analyze dimension reduction, factor analysis. Then we have to go for the principal axis factoring. Then okay. You can see the output here. This is the output. Initial communities are the squared multiple correlation coefficients controlling all the other items. What was the initial community for principal component analysis? So you can see here. Then again, you can see this too, right? Again, you can see these two eigenvalues. Then the other one is that now here it's given that I need to uh, factors no that's given, but we'll see then how we can do the fact analysis using these eigenvalues, right? So then again the same one, analyze dimension reductions, descriptive statistics. We can go analyze dimension reductions factor, right? So then now the dependent variable is the extraction method again. We can go for the based on the eigenvalues, based on the eigenvalues. Eigenvalues are only for principal component analysis. SPSS use the eigenvalues for the EFA, right? So when you look at the tree plot, so after drawing this tree plot, you are making decisions about the principal component analysis solution as a proxy for exploratory fact analysis. Right. Then here again another method, principal axis factoring, right? So again the same thing, analyze dimension reduction factor. Extraction method is we can change its principal axis factoring. Okay, so we can, if you like, you can change it to maximum likelihood likewise. Right, part diagram. So then here you can see after taking these eigenvalues, so you found that there are two things, that is XPS's anxiety and the tech anxiety. So then you can create these variables because these are latent variables. We can't take directly these variables. The relationship between the three tables. Right, it means that principal component analysis, familiarities, and total variance explain. So what are the relationships there? Right. Then one next one is maximum likelihood. Again, so here from here you can select maximum likelihood. Right. You can see here a significant chi-square means reject the current hybridized model. The chi-square value is chi-square value is significance. Therefore, we can reject the current hybridized model. Right? This is how we can use this principal axis factoring, or the maximum likelihood. Comparing EFA with this PCA, principal component analysis. That is the uh, similarities and differences we'll see there. Total variance explained by total community explained by total, not total experiences. not total variance. Second one, for both models, community is the total population of the variance due to all factors components in the model, right? When we see some rotation methods as well, quite simple structure, orthogonal rotation, that is very much, and the oblique, direct oblique rotations there. So this is a simple structure. Then here you can see then. So if you use this rotation method, so you can select into these three factors. Then here you can see then 1, 2, 3, it's created one factor. 4, 5, 6 create another one, and 7, 8 create another factors. So that is by using those things we are stacked that the given question actually using these methods. So then this is simple structure because this is only in three, but this is not a very simple structure. Most items high loadings then more than one factor. Factor three has high loadings. Here, factor three is there are in here. In that case, within we have to use these rotation methods, right? So without rotation, first is the most general factor into the most items load explain the largest amount of variance. So, but if it is not like that, is then if it is like this, no need to use these rotation methods, but it is in that way. So we need to go for these rotation methods to extract the factors from the given question. Correct. Without rotation, first is the most general factor onto the most items loads explain the latest amount of variance. So then here its method is very much orthogonal rotation makes. Maximizes variances of the loadings with the factor while maximizing the difference between the high and the low things of the particular factor. So then we can go for the rotation method. Then we'll go analyze dimension reduction factor, right? Rotation. We can go for rotation is very much rotation. Then number of convergence is given. Right, factor transformation. So we can see that rotate factor matrix, factor transformation matrix, and the rotated matrices. Right, the factor transformation matrix turns the regular factor into matrix to rotated factor matrix. Right, so we can change the directions using those things. And if you observe this, right, so then you can see unrotated solution is SPSS anxiety and takes on solutions. Right. So then these are the path diagrams actually. Right, that's what actually wanted to explain to you, because that if that question here is given, sometimes those variables are latent variables, right? Latent variables like any psychological construct वगैरह, just we can't measure it. So therefore we have to go for factor analysis and extract uh, the factors. Factors take extract කරගන්න ඕනේ ඔය විදිහට ගිහිල්ලා, right? So then here there are many methods actually, so you can go for the factor analysis, right? So then you can find these variables, right? So that you can construct. Right. So with that, any more questions to ask?
variable දැන් ඔතන නම් 8යිනේ තිබ්බේ.
Mm-hmm.
ගොඩක් තිබ්බොත් factor analysis එකේ අපි අර කියපු ඒවා කොයි එකද තෝරගන්නේ කියන ප්‍රශ්නේ.
ඒක මේ දැන් මෙතන දැන් methods කීපයක් තිබ්බා. ඒක මේ ගොඩක් තිබ්බොත් ඒක නෙමෙයි. ඒක අපි ගන්නෙ method එක select කරගෙන අපිට එන answers එක. දැන් අර දැන් මෙන්න මේ වගේ එකකට. දාලා බලන්න ඉස්සෙල්ලා දැන් කොහොම මෙන්න මෙහෙම ආවොත් ඔය table එකේ. right. මේ තියෙන factor analysis කරාට පස්සේ ඔය එක method එකක් දාලා බලන්න principal axis factoring හරි ඔය අර මොකක්ද කොහොමද මොකද මෙන්න මෙතනින් අපි බලමු analyze dimension reduction factors. So මෙතන තියෙනවා extraction methods. So මේකෙන් max මේ කැමති එකක් දාලා බලන්න. එකක් දැම්මට පස්සේ right, so if you have මෙන්න මේ වගේ table එකක් එනවා. මේ factors තුනකට වෙන් වෙච්ච එකක් එනවා. right, මෙන්න මේ වල තියෙන මේ factors වලට වෙන් වෙලා තියෙනවා නම් ඒ කියන්නේ එක එක වෙන වෙනම නැතුව වෙනම හරියට පැහැදිලිවම ආව නම් ප්‍රශ්නයක් නෑනේ අපිට. So then we can එතකොට අපිට මෙන්න මේ factor 1 කියන එකට මේ පළවෙනි questions තුන ඇවිල්ලා තියෙනවා. factor 2 කියන එකට මගේ question answer එකේ 4 5යි ඇවිල්ලා තියෙනවා. factor 3 එකට මට ඇවිල්ලා තියෙනවා 2ක්. මට මේවට නම් දෙන්නත් පුළුවන්. right, ඒ කියන්නේ ඒකට ගැලපෙන නමක් දෙන්න පුළුවන්. එතකොට ඒව තමයි අපි මයින් ඒව තමයි අපේ variables වෙන්නේ එතකොට. පැහැදිලිද? හැබැයි ඒක දැම්මට පස්සේ දැන් ওই වගේ එකක් දාන්නකෝ. එතකොට මෙන්න ඇවිල්ලා දැන් මේක පැහැදිලිව වෙන් වෙලා නැහැ. right, වෙන් වෙලා නැහැ. දැන් මට මේක factor 1 එක ගන්න බෑ. මොකද ඒකේ 3 එකෙත් තියෙනවා. right, so therefore then it's a problem. So what you need to do is ඊට පස්සේ අපිට එහෙම වුණොත් එහෙනම් අපිට මෙන්න මේ rotation method එකට යන්න වෙනවා. analyze dimension reduction factor, then මේ extraction එක නේ අපි කිව්වේ මේ maximum likelihood හරි ඔය එකක් අපි දාගත්තේ. එතනම තව තියෙන rotation එකක්. මෙන්න මේ rotations දාගත්තට පස්සේ මේ rotation methods වලින් පුළුවන් මෙන්න මේවා අයින් කරගන්න. ඒක දැන් මෙතන මම දාලා තියෙනවා මේ 100 මේ 100ක් ගියාට පස්සේ වෙනස් වෙන්නේ නැත්නම් මෙතන තව වෙන් කරගන්න 500කට හරි කමක් නෑ 5000කට ඕන ගානකට right, මේ වගේ වෙන් වෙන මේ මෙන්න මේ වගේ පැහැදිලිව වෙන් වෙනකන් ඔයාලට පුළුවන් මේ rotation methods වලට යන්න. එතකොට factors වලට වෙන් කරගත්ත හැකියි. right, so you have to check. හරි නේද? එතකොට මේ questionnaire එකක validity එක බලන්න තමයි අපි මේ factor analysis එකට යන්නේ. එතකොට pilot test එකක් දීලා කීප දෙනෙකුට 20කට 30කට වගේ දීලා ඉස්සෙල්ලා මේ factor analysis එක කරලා බලන්න originally questionnaire එක මේ දෙන්න කලින්. එතකොට results හොඳට reliable විදිහට ගන්න පුළුවන්. මොකද මේ වගේ high correlations තියෙන වගේ තමයි හැදිලා තියෙන්නේ. එතකොට ඔයාලගේ questionnaire එකේ ප්‍රශ්න හරියන්නේම නැත්නම් බලන්න මේ දැන් එක දෙකකට 3කට යන ඒවා තියෙන්නේ. ඒ ප්‍රශ්න අයින් කරන්න. right, අයින් කරලා ඉවරලා ආපහු factor analysis කරලා බලන්න. එතකොට ගන්න පුළුවන්. ගොඩක් වෙලාවට factor analysis වලින් questions අයින් කරන්න වෙනවා. right, so any more questions to ask? මොන හරි තියෙනවද? right, if not so we can finish our session. right, අපිට නවත්තන්න පුළුවන්. but so if you have further questions, it is open to ask the question, so you can contact your university members, so then you can ask the questions from them, so they will direct to me, then I can answer you. right, so when you are doing your research, so if you have any problems related to the analysis part, feel free to ask. So I'm always with you to help you. right, so again I'm asking any more questions. If not, so we can finish the session. ප්‍රශ්න තියෙනවද මොනවා හරි?
දැන් report එකට ගන්නකොට ඔය එක එක ටෙස්ට් වෙන වෙනම මේ අපි ගන්න ඕනේද වෙන වෙනම ලියන්න ඕනේද එහෙම නැත්නම් එක එක පොයින්ට් එකකට ටෙස්ට් ටික ඔක්කොම ලියලා ආයි ඊළඟ එකට එහෙම යන්න ඕනේද
නෑ
අපේ
ඒක
රිසර්ච් එක අනුවද?
නෑ රජිතා ඒක වෙන්නේ ඔයාගේ මේ ඔබ්ජෙක්ටිව්ස් අර රිසර්ච් ක්වෙස්චන්ස් වලින්. දැන් අපි රිසර්ච් ක්වෙස්චන් එකට අදාළවනේ අපි අපේ ඇනලිසිස් එක කරන්නේ.
ඔව්.
ඒකට සමහර විට අපි බලමු ඔයා බලන්න යනවා රිලේෂන්ෂිප් එකක් තියෙනවද කියලා.
හ්ම්.
රජිතා ඔයා මොකක් හරි පටන් ගන්නද තියෙන්නේ?
ඔව් සර් ඩේටා
හරි
ඇනලිසිස් තමයි දැන්
හරි
කරන්න යන්නේ.
තියෙන්නේ හරි ඔයාගේ ඔබ්ජෙක්ටිව් එකක් කියන්නේ මම ඒකට නිකන් කියන්නම් මතකද නෑ.
තියෙනවා සර් මේ මම මහවැලියට කරන්නේ රිසර්ච් එක.
ඔව් ඔව් හ්ම්
ඊ ප්‍රොකියුමන්ට් කියන එක මහවැලියට ගේන්න පුළුවන්ද බැරිද කියන ෆැක්ටර්ස් වගේ තමයි හොයන්න යන්නේ.
හ්ම්
එතකොට ඒක එක තැනක තියෙනවා බැරියර්ස් ගැන ආයි ඩ්‍රයිවර්ස් ගැන එහෙම තියෙනවා.
හ්ම්
මේ
එතකොට සමහර විට ඔයාලට ඔන්න අර අපි කියපු රිග්‍රෙෂන් මොඩල් එකකට වගේ යන්න පුළුවන් ඉන්නත් පුළුවන්. ඒක ඔයා මේ ක්වෙස්චන් එක අනුව තමයි තියෙන්නේ. එතකොට සමහර විට ඔය ඒ වගේ එකකින් ඔය මොඩල් එකකට හරි යන්න පුළුවන්. මේ යන්න ඒ වගේ චුට්ටක් බලන්න. ඔයාටම තමයි තීරණය කරගන්න පුළුවන් මේ කියන්නේ මම දැන් ඔයාගේ රිසර්ච් එක ගැන දන්නේ නැහැනේ. රයිට් ඒතොර රිලේෂන්ෂිප් එකක් බලන්න තියෙනවා නම් දෙකක ඔයාලට කෝරිලේෂන් එකට යන්න පුළුවන්. එහෙම නැත්නම් ප්‍රෙඩික්ෂන් එකක් තියෙනවා නම් යන්න පුළුවන් රිග්‍රෙෂන් වල. රයිට් ඒ වගේ ගිහිල්ලා චුට්ටක් බලන්න එතකොට පුළුවන්. right right හරි මං හිතන්නේ අනිත් අයට ප්‍රශ්න නැහැ. අපි එහෙනම් නවත්තුමු. මේ තවත් මොන හරි ප්‍රශ්න තියෙනවා නම් ඔයාලට අහන්න පුළුවන්. right එහෙනම් ආයේ නැවත දවසක අපි හමු. goodbye. right goodbye.